Hi everyone, welcome back. Today we're doing count the number of consistent strings. We're given a string allowed consisting of all characters that are allowed inside a word, and we're given an array of words. So we have to return the number of consistent strings or words in this array. So in the first example, we're given allowed equals to A and B, and words are equal to a single array consisting of 5 words. In this case, the word over here, AAAB and BAA are consistent since they only contains A and B. For the second example, in this case, we're given ABC for allowed, and words are this current array of 7 words over here. In this case, all 7 strings are consistent, so we return 7. For the final example, we have 4, we have CC, we have ACD, we have AC and D as consistent strings because only these 4 words consist only characters in this CAD over here. So every single word given to us over here can be up to 10 to the power of 4 in length, in this case for this whole string array. And for this allowed string over here, it consists up to 26 characters. Every single word given to us in this string array is up to 10 characters, and the characters in allowed are distinct, and both words and allowed contains only lowercase English letters. So for this question, the trick is to figure out how do we check if a character is consistent or not very efficiently. So one way we can do that is by using a data structure called a HashSet. So by adding every single character in allowed into this HashSet, we're able to check whether if a character exists in this data structure in O1 amortized time. So that's very efficient. And afterwards, what we will do is we will iterate through every single word in this string array, and we will proceed to check if they are consistent or not. So with that, let's get started. Let's define a hash set, and this hash set will contain characters. So I'm using the box type of character because unfortunately hash sets only accept box types. So I can't use the primitive character over here. Let's call this allowed set, and we will initialize this as a new hash set object. Once we're done, we will iterate through every single character in allowed. So we will use a simple index over here. So while I is equals to 0 and while I is less than allows length, after every iteration we will increment I by 1, and by using this I we can get the current character. So the current char will be equals to allowed charAt I over here. And what we will do is we're going to add this into the allowed set. And once done, we are pretty much ready to start checking if every word is consistent or not. So we will iterate through every single word in words. And for each of these words, we will start to iterate through every single character. So j equals to 0. J is the index over here. J less than word length. J plus plus after every single iteration. And similarly, in this case, we get the current char. This will be equals to word charAt j. And if this allowed set contains current char, then let's do the inverse actually. Let's define a boolean that indicates whether if this current word is consistent or not. So let's set this to true by default. So a word is considered as consistent till proven otherwise. So at this point on line 14, this is the condition where we indeed prove that it is not consistent. So if it is not consistent, we'll set it to false and we will break over here. And this will save computations for needing to go through the other characters in the same word. So after this for loop iteration over here, if the consistent boolean is still true, then let's define a consistent strings count over here. We will increment this by 1 if the word is indeed consistent. And the final step would be to return the consistent strings like this. So that's pretty much it. Let's look through the implementation to spot any syntactical errors. Looks fine. Let's try this with this test case over here. We do not have to trace out everything, but hopefully this will be clearer to our viewers on how this algorithm will work. So let's define this allowed set to be an empty hash set like this, and let's start tracing from I equals to 0. So the current character at I in allowed would be A, and we'll be adding A into the allowed set like this. I equals to 1, we get B at index 1 in allowed, and we add in B here. And this is the final character, so we will add C into allowed set as well. At this point, we are ready to use this set to check whether if a character is consistent or not. So let's start with the first word. In this case, we are looking at A, and in this case, inconsistent is consistent is true. So A in this case, J is equal to 0, and in this case, the current char at index 0 is A. And A exists in the allowed set, so this doesn't get hit, and we will increment consistent strings by 1. Now we move on to B. Similarly, we will refresh is consistent to true, J is equals to 0, and current character is equals to B. And because B exists in the allowed set, this will not get hit, and we will increment consistent strings by 2 again. This would be the same for C. So same thing, we will increment it to 3. Now we get a B for the word. For the character at 0, this will be A. This is still consistent. And for B, B exists in the allowed set as well. So we will end up incrementing consistent strings to 4. AC, similarly, we'll get A. A is inside the set, and C is inside the set. So we increment this to 5. Let's move on to BC, 0. B exists in the set, and for the second and final character, C exists in the set as well. So we increment consistent strings to 6. And of course, for ABC, it's pretty much the same routine. A exists in the set, B exists in the set, and C exists in the set, and we will increment consistent strings to 7. So this will give us the answer 7 over here. So looks great. Let's run this against our test cases. And this passes, thank goodness. And there we go. So let's start talking about the time complexity. So if we let M to be the number of characters in allowed, and N to be the number of words in number of characters, actually number of words, I guess this would be better. Then in this case, this would scale with respect to OM, because for every single character that is in allowed, we will have to do an iteration to add it into the hash set. And over here, similarly, it will be ON, because we will be iterating through every single word. If we would like to break down this time complexity even more, let's call this Z to be the number of characters. Then in this case, this operation over here will be OZ. And in the worst case, if every single word is consistent, then we will not be doing any early termination. So what this means is this would have a time complexity of OM plus ONZ. So if we remove the higher power, we just keep the higher power, then this will just be ONZ. For the space complexity, let's remove all of the workings again. In this case, this hash set would have the same size as allowed. So in this case, this is going to be OM. And for this, in this case, we are going to iterate through every single word. This word over here technically is a copy of every single word. So this is already going, this temporary variable over here is already going to be using OZ. And in this case, this is pretty much using constant memory. This is going to use constant memory. This is going to use constant memory. And yeah, that's pretty much it. And we are returning back a boolean, sorry, an integer, and that is constant memory as well. So in summary, our space complexity will be OM plus OZ, but that is pretty much trivial. If you wish to not measure the the space complexity by Z, then we would just, and if we just consider M over here, then the space complexity would just be OM like this. But if you want to be more pedantic, like what we're doing here, and keeping track of the time and space complexity by the number of characters, then this would make sense, specifically because the word over here is going to take up as much memory to keep track of the number of characters inside this for iteration over here. So I hope this was clear. I hope that this explanation was helpful to you. And if you find it useful, please give us a like and subscribe, and we will see you in the next video.